All right, guys, we're going to pick up question 33. So these are now 4 points each, so expect to do a little bit more work. The height in feet of an object dropped from the top of a building after t seconds is given by this equation here. Okay. How many feet did the object fall between 1 and 2 seconds after it was dropped? Okay, well, I have an equation. I'm going to go to my calculator. I'm going to type in my equation. Let's see. I'm using an x instead of a t. I always use x's and y's when I type into y equals. And I'm going to go to my table. And if you look at this table, when time, so let's see here, I have x and y, which I'm going to change. So we have x and y, but in this problem, the variables that we're using are t, that's time, and height, that's my h. I'll use a capital H because they are too. So at 0 seconds, the height is 144. At 1 second, the height is 128. At 2 seconds, the height is 80. So if you look at this, how many feet did the object fall between 1 and 2 seconds after it was dropped? So we're going from here to here. So I dropped the object. After 1 second, it's at a height of 128. After 2 seconds, it's at a height of 80. So 128 minus 80 means that the object dropped 48 feet. So there's my first part. The next part, determine algebraically, that means we have to do work, how many seconds it will take for the object to reach the ground. Okay, if the object is on the ground, then the height has to be 0 because the object's on the ground, there's no height to it. So if you look back at the equation on the top, where the h is, I'm going to put in a 0. 0 equals negative 16 t squared plus 144. The height is 0. I have to see how long will it take for that to happen. I'm going to subtract 144. Negative 144 equals negative 16 t squared divided by negative 16. And let's see here. I get a 9. To solve for t, I have to square root. So now t equals, now remember, when I square root, I get a positive 3 and a negative 3. But because this answer represents time, I'm going to take the positive 3 and let's see here. Oh, yep, seconds. And that's question 33. Question 34. The sum of two numbers, x and y, is more than 8. So sum means that I'm adding. X plus y is more than 8. When you double x, doubling means you multiply it by 2 and add it to y, the sum is less than 14. So you're reading and translating. Graph the inequalities that represent this scenario on the axes below. In order for me to graph, I need to solve for y. Let's subtract x from both sides. So there's my first one. So I'm going to go ahead and graph that. Now, I'm going to graph this one on my own. Maybe I'll use the calculator for the next one. My y-intercept is 8. So I'm going to go up to 8 on my y-axis. And the slope is the number in front of x. The slope is negative 1. So I'm going to go down 1 and over 1. That's my slope right there. And I'm just going to get myself a bunch of points. Now remember, this is a dotted line. So I'm going to steal a ruler. Remember, on the Regents exam, you won't have a ruler, but if you ever want one, just raise your hand and we will come and give you one. So this is my dotted line with arrows. And I'm going to label it. And now I have to shade it. This says y is greater than, so then I shade going up. So that's my first inequality. Now I have to do the second one. I have to subtract 2x. Okay, now this one, I'm going to graph it on my calculator just to kind of show you what you can do. If you go to y equals, I can still type it in. Negative 2x plus 14. I'm going to go to the table. And I'm just going to pick some points and plot them. Whatever ones fit on my graph paper, that's what I'm going to plot. I don't know if my graph goes up that high. I'll try. Negative 116. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Negative 116, that's the very top of my graph paper. And then I have 0, 14. And then I have 112. So I'm going to go over 1, 2, 4, 6, 10, 12. Once you get yourself a couple points, you should see the pattern. If you'll notice, this is I'm going down 2 and over 1, down 2 and over 1. So now I can just keep that going without my calculator. Once again, I have a dotted line that I'm going to draw. So let's see here. And I'm putting arrows on it. And I'm going to label this one. And I have to shade. Y is less than, so I want to shade lower. So here's my dotted line, okay? I'm going to shade where the y-axis is getting smaller, so I'm going to shade all of this. So now everything in here, this little section in here, this is my solution because that's where I'm double shaded. Okay. At the bottom, Kai says that the point 62 is a solution. Determine if it is correct and explain your reasoning. Okay. 62. That's this point right here. That's actually the point of intersection, which we have talked about this before. Does the point of intersection count as a point in the solution? In this case, no, it does not, because it's on two dotted lines. So, Kai is incorrect because the point 62 is on dotted lines, and they are not included in the solution. And that's that. Another 4 points. Question 35. Big reading question here. If you look at this one, an airplane leaves New York City and heads towards Los Angeles. As it climbs, the plane gradually increases its speed until it reaches cruising altitude, at which time it maintains a constant speed for several hours, as long as it stays at cruising altitude. After flying for 32 minutes, the plane reaches cruising altitude and has flown 192 miles. After flying for a total of 92 minutes, the plane has flown a total of 762 miles. Determine the speed of the plane at cruising altitude in miles per minute. Wow, lots of information. First off, after flying for 32 minutes, the plane reaches cruising altitude and has flown 192 miles. Okay, so 32 minutes and the plane has flown 192 miles. So I'm just kind of jotting this info down. After flying for a total of 92 minutes, the plane has flown a total of 762 miles. Now they want the speed of the cruising altitude. So if you look at this, This is when we reach cruising altitude, right here. It takes 32 minutes and 192 miles to reach cruising altitude. So what I need to do is I need to subtract this, because those 192 miles that it went, that's when the plane is flying up. So that's when I'm gaining altitude. So at that time, I'm just gaining altitude. Then I reach my cruising altitude, and now I'm flying in a straight line, okay? So that first 32 minutes, I'm like, woo, 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 here I go, I'm flying, flying, flying. That's my 32 minutes. That's my 192 miles. Now I'm at a cruising altitude. That's when I start to level off, and now I'm just flying straight to LA, okay? So that's what you want to pay attention to. So I'm trying to find the speed of this cruising altitude up here. That's what I'm looking for. So I need to subtract this time and these miles, because those don't count, okay? So I need to do 762 minus the 192, and when I subtract those, I get 570 miles. I also need to subtract the time. 92 minutes minus the 32 minutes means a total of 60 minutes. So now if I want the speed of the plane, I need to know the distance divided by the time. This is actually something we did in class recently. So 570 miles divided by 60 minutes. And look at, they want miles per minute. Miles on top, minutes on the bottom. So when I divide those, 570 divided by 60, I get 9.5 miles per minute. That's my answer, okay? Write an equation to represent the number of miles the plane has flown, that's y, during X minutes at cruising altitude only. Okay, well, think about all that work we just did. If I'm flying 9.5 miles per minute, then what if I fly for 2 minutes? What would I do? I would just multiply 9.5 times 2. So if y is the miles, it's 9.5, because that's the speed, times however many miles I'm driving, or excuse me, flying. And remember, it's only at cruising altitude, which is why I can use this number up here, because this is the speed at cruising altitude. Now, assuming that the plane maintains its speed at cruising altitude, determine the total number of miles the plane has flown 2 hours into the flight. First of all, we're not talking about hours. So this is 120 minutes. We have to translate that right off the bat, okay? So now, I know that the first 32 minutes, the plane flew 192 miles. Remember, that's when the plane was gaining that height, gaining altitude. That was the 32 minutes and 192 miles. Then we started cruising along, okay? So that means if I spent 32 minutes right here rising up into the sky, then I need to do 120 minus 32, which gives me a total of 88 minutes. That's how much time I spent at cruising altitude just going straight along through the sky. So, well, what's the speed? Those 88 minutes, I was going 9.5 miles per minute. That's from the previous section. That's my equation. So I spent 88 minutes at cruising altitude. When I multiply those, I get 836. Now remember, that's how many miles I went at cruising altitude. I have to add to that the 192 miles I spent gaining altitude. Add those up, it's a total of 1,028 miles. Big reading question here. Hopefully that makes a little more sense now. Okay, last 4-point question. On the set of axes below, graph. Okay. First thing I have to graph is g of x. No problem. Y-intercept of 1. My slope is 1/2. Up 1 over 2. And just keep going. I'm just going to graph that line. It's just a line. Remember, you can use your calculator if you need to. If you forget how to graph the slope, then just put it on your calculator. And I'm going to label that g of x. Okay, now I have to graph f of x, which is a piecewise function. That means that you want to split this up into 2 pieces. The first thing I'm going to do is go to my calculator and I'm going to type in 2x plus 1. And I'm going to go to my table. I'm only graphing this line when x is less than or equal to -1. So on my calculator, I want to start at -1 and plot that point. So -1, -1. I'm going to plot that point. That's a closed circle because that has an equals to sign. Now, from here, I'm plotting points when x is less than -1. So when x is less than -1, that means I have to go to -2. And I'm going to plot that point, -2, -3. And then I'm going to plot these points that are less than -1. So -3, -5, -4, -7. And I'm going to sketch that in. Now remember, I'm only plotting it when x is less than -1. So when I draw this, look what I'm doing. I'm stopping at that point. This right here is -1. I'm only graphing when x is less than -1, which means to the left of -1. So those are the only ones I'm plotting. Now I have to do the same thing with the other piece. So now I'm going to graph. I'm going to go back to my calculator, clear this out. 2 minus x squared. I'm going to my table. Now, this one is when x is greater than -1. Notice that's greater than, so that means I need an open circle. So at -1, 1, I'm going to plot an open circle. -1, 1, I'm going to plot an open circle right there. And I want to plot all the points where x is greater than -1. So that means 0, 2, 1, 1, 2, -2, 3, -7. And that's just a little upside down parabola. And there you go. Okay. Now, I have to answer the question. How many values of x satisfy the equation f of x equal to g of x? Explain your answer using evidence from the graph. Okay. If they are equal, that means points of intersection. So how many values of x satisfy that equation? One value, because the graphs intersect one time. That's right here. There's only one time where those graphs cross. That's the one solution. Alrighty. We made it through part 4. So those are all the 4 points. Nice job.